Okay, everybody. I'm Ishan. I basically am software engineer with Loft Labs, and we are the maintainers and the developers of the Vcluster project. And today we are going to basically talk a little bit about the Vcluster project itself, what exactly Vcluster is and how it is implemented under the hood, how things work, and also in terms of Knative, how we have kind of optimized the Vcluster project with something that we are calling Vcluster plugins using the Vcluster SDK, and it's going to help the Knative community, I would say, when we have scenarios where we have multiple vClusters for multi-tenants, each tenant having their own Knative installation for their workloads. And how can this plugin architecture basically help or optimize this whole scenario? So yeah, so I'll start with the slides now. So basically, if you talk about vCluster, every virtual cluster is going to have its own API server, and in terms of which API server we are talking about, so we have currently 4 official supported API servers. One is the K3S, which is the by default applied API server. Other flavors that we have are vanilla KS, we have K0S, and we also support EKS. And when it comes to like what kind of advantages a vCluster would have, like it is better isolated than your regular namespaces, and it's still cheaper than creating real Kubernetes clusters for every tenant. So it's kind of somewhere in between namespaces and uh, fully dedicated Kubernetes clusters. So if I try to explain you, so in terms of isolation, we have this comparison chart where vCluster is kind of giving a right balance between separate namespace for every tenant versus separate cluster for every tenant. And as we can see, when it comes to isolation, we have pretty strong isolation vCluster, and same thing for access for tenants, where every tenant inside the vCluster can be the admin of that vCluster. Just a minute. Okay, Ivan has a question. The isolation is at the control plane level, right? Doesn't protect against host level attacks somehow. So yeah, I think what you're trying to ask is that isolation is like if the attack is on the host clusters API server, uh, then any protection is provided by vCluster. I believe not in that case. Uh, but yeah, every vCluster will. Okay, that's on kernel or node kubelet. Uh, on kernel or node kubelet. Okay, so attacks on node kernel and the node kubelet. I think not really, because we when it comes to vCluster, we are not directly dealing with like managing the nodes themselves. We basically fake the nodes, the actual host nodes, and sync them up into Vcluster. So I'm not pretty sure that Vcluster directly would provide any any safeguarding features for the node itself. Um, yeah, apart from that, we have like cost and resource sharing, which are like pretty cheap and easy, and like very low overhead. So anything else? Okay, so a typical vCluster usage flow would be something like we initially create a vCluster on the host namespace, and that will be followed by, so when you say a host namespace, on the host cluster, we create a new namespace, and a new vCluster is part of that namespace. Um, and the next is typically inside the vCluster, you would add some more namespaces depending on different software stacks or things like that. Um, and that is followed by we selecting a particular namespace for actually deploying our workloads. And once you create a deployment, basically what happens is the actual pods created by the deployments never run inside the vCluster. Instead, what you see here, pod 1, pod 2, and pod 3 are basically fake pods, and we basically sync the actual pods from the host namespace of which are basically running on the host cluster, and they are constantly in sync with the fake pods that you see inside the V cluster. So typically, this would be the kind of usage flow of any vCluster workload deployment. So, uh, so these are basically not all the exact number of resources, but basically these are the kind of resources that whenever you create a vCluster using the vCluster CLI or the Helm chart, these are the basic resources that are created for every vCluster instance the host in the host cluster inside the namespace. So you'd have isolation with RBAC service accounts and network policies, and you can toggle source quotas. All these can, a lot of these configuration objects can be overridden based on the requirements. And then on the right, as you can see, there are some stateful set, which is basically the core of the V cluster. We can take a look at it in a bit more detail in the following slides. And recently, we've also added some more config maps that would allow you to initialize a vCluster with particular charts deployed, or maybe some initializing manifest files that you want inside the vCluster as soon as it is created. So uh, moving on. So as I already told you about this, that the stateful set itself is the core of the vCluster, and it will have an API server, which is K3s by default, and a sidecar syncer, which is what does all the syncing of the core resources of Kubernetes when it comes to pods or config maps and all the kinds of resources. The code resources are synced up and down and always kept in sync with the host resources and the virtual resources inside the virtual cluster. So Yeah, so in terms of like when we say uh, what would be the typical deployment of a multi-tenant vCluster with each tenant having a Knative installation for them would look like. So we have the host cluster here, and we have three instances of vClusters running inside that host cluster. So typically, I've just named them as vCluster 1, 2, and 3. And um, for simplicity's sake, even the namespaces are same as the vCluster names. So basically, these three vClusters would be existing inside three namespaces of the same name. And this dotted boundary can basically be served as a, I would say, um, uh, the separation line between the host cluster versus what's in the virtual world. So in case we have Knative deployed inside every vCluster, right? So as you can see, we have a we have a Knative component showing up here. And what's going to do is, at the end of the day, everything is going to run on the host cluster itself. Hence, you have these Knative components which basically run uh, maybe inside the Knative. Once you install Knative, you have the Knative serving namespace, and all these components run as pods inside that namespace. So I'm just assuming the same thing, but just inside the vCluster itself, and inside the vCluster, you would have a namespace called Knative serving, and then these are synced down to the host cluster. But because you are installing Knative in every vCluster, so you are going to end up with a copy of these resources for every vCluster. So if you have three vClusters, you will have three copies of Knative in your host cluster, and you would be running, for example, three copies of autoscaler pod in your host cluster. So uh, the general way of execution would be very similar, that you create a Knative service, which the Knative controllers basically intercept and then start creating other resources like config, revisions, and deployments. As soon as you have deployments, you will have the pods, but those pods won't be running because they are inside the virtual cluster. So the syncer would sync down the pods to the host, and the pods would actually start running on the workload. We have some chat. Okay. Um, so yeah, so the same thing happens with the services. I've not shown the services here, but basically that would be the very similar case with service as well, where the service will also be synced down, and the core vCluster syncer would keep things in sync. So this is typically what really happens in a general scenario. And what we want to enable is what I'm going to show in the next slide. Uh, yeah. So instead of Knative serving being installed for every vCluster, and that basically means that you would have n copies of Knative components for n number of vClusters. What we are saying is that we just have one cluster-wide installation of Knative in the host cluster, as you can see here, which would be the Knative serving namespace, and all the components of Knative are installed here, they reside here. And for every Vcluster, whenever you create a Knative service, the cluster-wide Knative should be able to pick this Knative service up and act on it, just like it was acting in the previous slide. But instead of having every component repeated, we just have a central component that can uh, do the heavy lifting for us, and the pods and other core resources are automatically being synced by the Knative uh, by the uh, by the uh, by the syncer of vCluster. So this is typically the goal that we have uh, with the plugin interface, that instead of having multiple installations, you write the plugin and it should be reusable across vClusters by staying deployed in the host cluster. So, so here's the details or basically a rough architecture of how this is implemented and how the plugin currently works to some extent. And we'll also go through a basic run of this. We have a demo as well. So typically we have the plugin plus syncer here. In the previous slides, we just had the syncer, which was already syncing the core resources like pods and services for us. Over here, we also have another component called plugin. So basically now the stateful set that I showed you in the previous slide, which had two containers. One was the API server itself. The second was a sidecar container, which was the syncer. Now, in this case, we have the third component, which is the plugin, which works along with the syncer, I would say. And basically, the plugin is what knows about the domain specific syncing, uh, syncing information that for particular plugin, let's say Knative or Tekton or whatever. So like how and which resources are need to be synced up and down, and what needs to happen. Okay, I think we have some Q&A. Something is copying Knative service out of the vCluster API server into the host cluster API server. Or is the Knative serving controller running against multiple API servers? Okay, Ivan has a question. I think I cannot hear Ivan, but is my screen able to show the question that Ivan has? Okay, I'm not sure. But basically what he's asking here is that is Knative service popping out of the vCluster into the host cluster, or is the Knative serving controller running against multiple API servers? So in the previous slide, if I just go back, in this case, what I'm trying to showcase is that for every API server, you have an installation of Knative. So yes, the Knative serving controller is running against each of the API servers inside these vClusters. So basically, although it is running inside, like everything that runs on the host cluster, but basically it's running against the API server inside this vCluster, not your host cluster. So there is no copying of the Knative service to and fro or in and out of the vCluster in this case. And the serving controller is running against the virtual API server of each of the virtual clusters. But in this diagram, what we want to implement is something reverse, where the Knative controller is running against the host cluster's API server, and uh, the Knative services which are created inside the Vclusters are basically synced down, but they're synced down in the way that they're still isolated in their own namespaces, so they don't interfere with any other Knative services from other virtual clusters. And then the Knative serving controller would act on them, would create the deployment revision and the configuration revision and deployment and resultant pods, and you would start seeing the workloads. Um, Another question that Ivan has raised is, it looks like in this configuration, you can see Knative service config revision, but not the pods which are created in the host cluster. Yeah, I think you are talking about this diagram. So yes, as I said, that this is not like the complete thing over here we have, and this whole plugin is still like a work in progress. So the problem here is, if I sync these pods as well back up, there's no chat. Oh, okay. Okay. Yeah, but you're right. In this case, the Vcluster, you would not be able to see pods right now, because if I sync the pods back up, they would also like clash with the core syncer that Vcluster has, which tries to sync them down again with the host cluster. So there would be kind of a race condition right now. So the first goal of this plugin, at least for the first release, is that we sync all the Knative specific resources, and then we might find a way around marking things like deployments and pods so that they are bypassed by the core syncer and only synced up by the plugin, so that there's no race condition between the plugin and the core syncer for the core resources. So right now, the plugin's only responsibility is syncing uh, and maintaining the fields of each of these CRDs, which are only in the domain of Knative, and the core resources are not part of that responsibility right now. I think okay. Yeah, so I'll just explain a little bit about this design as I was explaining the plugin and syncer thing. So as you already understood that plugin and syncer in this design would, so syncer is already the core component of Vcluster along with the API server, and the plugin forms the third sidecar of the stateful set that I showed. And basically, the reason that I have put this whole box at the boundary of vCluster and host cluster is because the plugin and the syncer have information, or basically uh, the Kubernetes context of both the vCluster API server as well as the host cluster API server. So it can talk to both the API servers. That's why it sitting on the boundary of this whole division of the virtual world and the host world. Uh, and basically, the typical flow is somewhere very like wherever you see the red arrows is where the plugin steps in, and um, where so we'll talk about this. Let's say the Knative service created by a vCluster user as soon as, first of all, the plugin would also pick up CRDs from the Knative installation on the host cluster and make certain CRDs available inside the Vcluster. So you can always specify which specific CRDs you want. So right now we only have support for the case service, config, and revision. We are also working on the route spec as the next step. But right now, we do these syncing of these three right now. So this allows you to run commands like kexplain case service in the vcluster without installation of knative inside the vcluster. So the vcluster installation on your host cluster is enough for you to get or create Knative service, config, or revision directly on the vCluster. So you start with a simple Knative service, and as soon as you create it, we have the plugin, uh, and we have basically something called in terms of code, coming in terms of code out of the architecture, we have something called vcluster sdk that allows you to implement these things with a relatively more easier way and directly plug in with the core syncer. So basically you have functions like sync down, sync up, and sync, which basically get called. So every time a new case service, for example, is called, you would get a call to your sync down function, and you basically compare the virtual object and the physical object and see what fields need to be synced and what fields don't need to be synced, or like what fields don't exist at all. So in the first instance, you will have the virtual object directly entirely as you defined your Knative service, but your physical object to your sync down function as a parameter would be an empty object. So basically you would decide that, okay, I need to sync the whole uh, service as it is down. And basically, it would be a typical reconcile kind of a step, and you would create the Knative virtual service into the physical service. And uh, the plugin has some helper methods for that. And we also have some labels that we apply to this Knative service so that we are able to identify a Knative service that is being managed by a vCluster versus something that was created directly on the host, which might have the same name or maybe like even created by another vCluster which runs on the host cluster. So that kind of isolation and identification is done through application of a combination of some name mangling and also with some labels are applied, which can be helpful in determining which vCluster is the owner of a particular Knative service, for example. Uh, as soon as this lands in the host cluster world, we already have Knative installed on this host cluster in the Knative serving namespace, as you can see here. So the Knative serving the Knative serving controller would act on it, start creating the configurations and revisions. And since plugin has multiple controllers registered for all three CRDs, we'll start getting similar events for our syncers, for config and revisions. So when I say syncers, like they are very much similar to the core syncers. It's just that we have a core syncer in as part of the vCluster core itself, for example, for pods and services. Whereas the plugin would have a dedicated syncer that we implement out of the vCluster core as a plugin. So the syncer for config CRD would get called with basically the virtual object as being nil and the physical object as the configuration object. So just the opposite is going to happen here. And based on which kind of object is nil or which kind of object got updated, we can decide about what kind of function do we need to call. So for example, in the first case, when we had the virtual service and the physical service was nil, we know that this has to be a sync down. So we call the sync down method. As soon as you create the key service, uh, the Knative controllers will start acting on it, and a lot of fields in this case service will be changed or modified. And in those cases, we would have both the objects. We would have the virtual object, we will have the physical object. Since both of them exist, we have the logic in the plugin is that you call the sync method. So you have sync down, you have sync, and you have sync up. I've not shown the sync method in the diagram, but the sync method is somewhere where you have both the objects and you implement the logic where you need to calculate which field got updated and which should be replicated up or down, like uh, what values should take precedence and which way the sync should happen. So it's more like an update kind of a function where you decide and you write the logic for copying of fields and which fields get, for example, the status in this case will always come from the physical object and you never try to replicate the status from the virtual object. So whenever there's an update in the status field, you always copy it from physical to the virtual. Whereas when you say, let's say there's a difference in the spec field, the precedence is always given to the virtual object because you may be changed the image tag in the virtual object and you now want that to reflect in the case service. So in both the cases, the sync function would be called, but the logic is written by the plugin implementer of which fields take precedence and which get synced up or synced down. Um, in case of the config, it's going to be just the reverse, that we don't have the virtual object initially and we have the physical object. So we get a sync up call and we sync everything up to the upper object and we start seeing the config. And same happens with revisions. We have a separate indexer which is needed because the kind of ownership labels that we apply to Knative service when we sync it initially with plugin are not copied over to this to the revisions. So the Knative, for example, it's like managed by label, for example. These are copied over by the Knative controllers in in case of config, but whenever they create the revision object, those labels are never copied. And hence we have to maintain a separate indexer. This indexer allows the plugin to keep a track of which revisions are particularly owned by this particular config. And this, like when you start imagining that you have multiple configurations, multiple Vclusters, uh, each having their own plugin and indexer. So you would have this indexer as a helper to understand whenever a revision event comes in, that is it being managed by the configuration which is being watched by this plugin, or is it a revision that is not the concern of this particular Vcluster? We were able to do this without the indexer in case of Knative service and config because the labels existed that were applied by the plugin. But when it comes to revision, those labels are not propagated from the config object to the revision object. Hence, we need this indexer, helper indexer, which keeps a track of which vCluster a particular revision belongs to, and should it be synced with this particular one or some other ones. So this is basically where the indexer comes in and helps us resolve only the revisions that are belonging to this particular vCluster, and also help us translate back the name when it comes to ownership, that which revision is being controlled by which configuration. Because a lot of name mangling is also happening between these syncers from the virtual to the physical world. So yeah, I think we have some more questions. Think, uh, do you copy over the owner references for revisions? That's how we actually keep track of. Yeah, yeah. So that's where the indexer comes in. So we do copy the owner references, and we try to update the owner references once you have the revision synced up. The configuration object name would be translated, and the physical name and the virtual name are translated accordingly, and the owner references for the virtual revision versus the physical revision would also be different, because the configuration name here is a little bit mangled versus the actual configuration name. So in the same way, we have to use that mangled and unmangling of those names between the virtual objects as well. But yes, we do like all that is part of this metadata translation to and fro between virtual and physical thing. And that's where this whole indexer thing comes into play, when it comes to uh, like implementing this whole thing. So I think this should probably be it, and we can jump to the demo, I think, if we have more questions, or would it be good to jump? Uh, I think people are not there on the chat. Uh, okay, not sure. All right, I will just uh, jump to the demo in that case. I'm just starting up the code. So in the meantime, if any more questions or anything on the chat, just waiting for it. Okay. It's taking a little bit longer because I think the screen sharing is on, so my machine is a bit slow. Okay, so on the left we have the controller plus, the vCluster plugin running, and I will also start the vCluster here. Oh yes, we have. So So on the right, as you can see, the context is the vCluster, Knative vCluster. So I have this vCluster created here. I can show you vCluster list. So we have one vCluster named vCluster Knative in the vCluster Knative namespace. and it's running. So on the host cluster, which is Docker desktop, as you can see here, I can show you the stateful set that I was talking about. And if we see what's inside the stateful set, uh, we have three pods running here, as we talked about. Uh, so basically, the Knative plugin itself uh, is running as a sidecar. We have the sinker, which is the core sinker of the Vcluster, and we have the K3s Rancher as the API server running. Okay, we have one more question. Where can we access? Oh, okay. Uh, I think it's on the YouTube channel for the recordings, but yeah. So basically, we have the stateful sets here, and already, if you can see, um, these are the logs from the plugin, and as you can see, we have kind service and kind configuration as the CRDs, which are already being synced with the virtual cluster. So as you can see, I just created the virtual cluster right now, and I did not install Knative into it. But we still have the Knative services, as you can see, and I can even show you like, okay, explain. See, so we have the Knative service inside the Vcluster. This is the Vcluster. Yeah, we have the Vcluster. Yeah, this is serving and quick. So we have the configuration as well. So we have the CRDs already being synced by the plugin. And now I'm just going to, yeah, so just a minute. Yeah. So I'm just going to create this very basic Knative service here. And this will be created in context of the virtual cluster, and we should see it getting synced uh, to the host and all the updates applied. If, yeah. So as you can see, we have the service created. We have it on the left on the Docker desktop, and also there were some updates. As you can see, sync was called for this particular service. We had update and multiple times called to sync as and when the actual controllers acted on the physical service and updated various fields and status. We got sync method called and they were reflected into the virtual service. So I can show you the exact service here. You can see this was the spec that we created in the virtual service. So on the left is the physical, and on the right is the virtual. As you can see, we have some labels applied, object name, and also some things like, sorry, the labels are here, managed by with the namespace and the actual vCluster name that owns this particular resource. And these labels are not copied over by the when revisions are created. So uh, we have to have those indexers, the helper indexers, which help us to identify which revisions are owned by vCluster Knative vCluster versus other vClusters and things like that. But basically, as you can see, we have the same name, and the status fields are also reflected between the virtual and the um, uh, physical names. I am not sure if Magic DNS is working on my system right now. Let's try and see. No, it's not working very well. So probably some issue over there. Yeah, uh, but basically, if I go ahead and change the um, image tag, for example, we should see that getting reflected on the left. And yes, we got to see that. And I think if I open this now, we should have, yeah, we have the new image defined. And as you can see, the revision is also updated to revision 2. If I open revisions here, so we have two revisions. The first was with point like 1.0 versus the second is 2.0. So I think the image should show here. Yeah, this was 1 versus this was 2. Yeah, this is 2. And I'll come back here. So this the virtual service, the virtual key service is now using the is now pointing that it is targeting 2.0. I don't seem to have the magic DNS working on my system right now, so that's why this is not reflecting properly with the slip IO. Instead, it's uh, reverting to example.com. So maybe, yeah, it's not going to work for the URL part, I think. Otherwise, I could have demoed that as well. But yeah, it's not working right now. So yeah, but we have a lot of tests as well when we talk about code, which kind of work with the uh, the magic DNS, and these URLs are reachable. So uh, so we have elaborate tests for Knative services over here. We are also implementing tests for revisions and configuration and routes. Um, as part of, yeah, I think we have more questions. No, right? Okay. I think that was it for the demo part. We can have any more Q&As or any more uh, things in general that people might want to ask about.